This is the metal insets material, and we're going to be looking at these for equivalency. And here you can see we have a whole square, and then the 8 other frames are divided in different ways. So you'll see at the top row we have them divided into rectangles or squares, and then we have the others are divided into triangles. And if you look in the divisions of them all, we see that we have halves and we have quarters here, and then again, it's divided into quarters as well, but just in triangles. And here we have it in eighths, 8 different rectangles. And you can see that each of these are a rectangle. And then we have eighths again on the lower frame, but these are all divided into triangles. The last frames, we have them divided into sixteenths. These are 16 little squares, and the other is then 16 small triangles. So we're going to be using these to look at equivalency and congruency and just seeing patterns with these. So the first thing we want to look at is congruency, and congruency is the same thing. So we can look over here and we can say, okay, these two are exactly the same. They're halves, and we can put them up to each other and we can measure the exact size and angles. These are exactly the same. So these two are congruent. Here we can use the symbol for congruency, and we can work together with these and find different congruent forms. So again, we have 2 identical triangles here. We can measure them up to each other and see that all the angles and the sides are all the same. Therefore, those are also congruent. And as you work through each of the pieces in the set, in each of these frames, are going to be congruent to each other. All of these, the way they're divided. So these rectangles will be congruent to each other, the squares, and so on. So now we want to continue, but looking at things that are worth the same value, take up the same amount of space. So if we look, these are split into halves. So this is half of the full square, this rectangle. And then we have the same square split into half, just a different way. So now we have it split in half on the diagonal, which makes it then into a triangle. And now we can say that these are both halves. They're not even close to the same shape, but they are equal in the sense that they take up the same amount of space. They're both half of this frame, half of the big square. So we call this equivalent, and we show the sign for equivalency, which is the equal sign. So they are equal, they have equal area, but they are not the same shape. So we're just going to play around and make different shapes. These two are then equivalent because they're both quarters. And here we have 2 eighths that are the same size but not the same shape. And again, we have 2 equivalent pieces that are the sixteenths. So we get to play around and test out for equivalency with all these figures. And we can puzzle together different things. So if we want to take different shapes and puzzle them together, we can do that as well. So here we can say, okay, we have a half as a triangle, and then we have a half using 4 eighths, and that gives us a half as well. So these are equivalent, and we can just make different combinations, and children can play around with what is equal. These two, you can see they are equivalent. They are the same. They're 2 eighths, but when we puzzle it together, you can see that they are absolutely equivalent because they make them the same shape. So when we rearrange them, they are actually congruent as well. So we're going to just work around with these, playing around, moving them different places, seeing, and you can also replace them in the frames. So if I were to move one into each of these spaces, I can rebuild it and I can show that these actually are the same space. They do take up the same amount of space, so they are equal. And I can just start puzzling around within these and just experimenting. So then the last thing that we're going to do with this material is called similarity, and we're looking for similar shapes. So we start with our square, and we can find another square here. And we can see it's a square, but they're absolutely not the same size. And they're not equal, but we can see that the angles are the same. And when we slide it down, we can see all the angles are the same and the sides are proportionate to each other. So a square means that the sides are all the same. Therefore, we can see that the sides are the same length. This one happens to be half of the length or the height of the other. So they aren't congruent and they aren't equivalent, but they are similar, and we can introduce the similar symbol. And then we can find another square, and we can say the same thing. It's also a square, so the angles will be the same, and the sides will be proportionately the same, but they are not congruent or equivalent, therefore they are similar. And again, we're going to use the material to play around and find other similar shapes. Again, with the triangles, we can do it by finding the right-angled triangle, and then we see that, okay, the angle is the same. And with triangles, if the angles are, all three angles are the same, then we know that they are similar. And there's a reason for that, we'll get to it later. So then we can find, again, we have another triangle here where the angles are the same and we have the proportionate sides here. But again, the angles, if all three angles are the same, then we are going to have similar triangles, because they're not the same lengths of the sides, but they are the same angles. And again, we have the fourth one. So all four of these from the frames are similar. They are not congruent, they are not equivalent, but they are all similar. And we can make a nice little sequence here, putting them in order, and we can see they are similar, they just get smaller and smaller. And you can see the size difference as you look from one side to the other. They're all similar. So now we have a new set of frames here, and these are the triangle metal insets. And you can see they are divided into different ways. We have a whole, and then we have two halves. We have it into thirds, and divide it into fourths again. So we're going to look at here to see whether we can find congruency, equivalency, or similarity within this material. So now we see we have a whole. There's nothing else unless we use a full frame, but when we pull out the two halves, we can have a look and we see they're exactly the same. We can hold them up, measure them, and we know that they are congruent. So within the frames, each of the pieces within the frames are going to be congruent, and you can measure them, both the angles and the sides, and it's very clear to see that they are congruent. They're exactly the same. Again, these are going to be congruent, these are going to be congruent. It's the same within the frame, like we saw with the squares. So next we want to be looking for equivalency. And this is a little bit tricky because you can see we don't have many different shapes. So we're going to let's look at this one here, the half. And what is equal to a half? We have to go all the way to our fourths and pull out 2/4. So when we put that together, then we can say that these are equivalent. And of course we have to puzzle it together. So there's no shapes here that are equivalent on their own. We have to puzzle two together to make a figure that is equivalent. So now we're looking for similarity in the triangles, and to do that we actually have to look at the different types that we have in the frames. We have an equilateral triangle, and then we have a right-angled scalene triangle. In other words, the sides are not the same length. And then we have three isosceles, or the same, two sides are the same, isosceles triangles that are actually acute angled. So none of these three are really the same. There's no three triangles until we get to the last frame, and this again is an equilateral triangle. And if you want to test that out, then you can just take and turn it in the frame, because if it is equal all the way around, then it will be able to turn in its frame. And we can test both of these, but we can see they are equilateral triangles. So we can say now that these two are similar, and they'll have the same angles, even though they have proportionate. Obviously this one we can't turn in the frame, therefore it's not equilateral. And it's easy to see that, but the children can test it out. So in these frames we have these two that are similar. You can see the angles, they're going to be the same, and the sides are proportionate to each other. And in a triangle, if angles are the same, then they are similar. So now we're going to look at congruency, equivalency, and similarity within the circles. And we'll use the fraction circles for this, but you can also find circles in the metal insets cabinet of varying sizes. As you can see, this is a bit smaller than this hole here. So here's the hole, and if you want to do congruency with these, you need to find ones that are equal to the hole. So you would build using the different fraction circles to make a hole, or the pieces within the frames are also going to be congruent. So a half is going to be a congruent to a half. Here we have the full circle, and we can also then create circles using the different fraction pieces. Equivalency, we can do the same as we would do with the fraction circles when we're actually working with fractions, where we say that 1/2 is equal to 2/4. And then we have equivalency. So it's really the same that we would do when we're working in the introduction with fractions. So again, we can play around with all of the fraction circles to find out what is equivalent to each other. To find similarity in circles, we can't use the fraction circles anymore because obviously they're all going to be different sized fraction pieces. But we can use the whole circle, and we can use the other circles of varying sizes from both the metal insets but also the geometric cabinet. So we can find different circles, and circles are circles. They just are varying in diameter. So we can find any circle within the classroom, within the environment, and we can say that they are similar.